Okay, so I was asked some time ago to tell you about the international and national reputation of the Institute for Space Aeronomy. And as many of you know, there are many ways to evaluate the production, the scientific production, and the impact of a research group or a university or research team. The most common one in the academic world is to look at the publications and look at citation indices and so on. And that has been done and is being done by also in Belgium, of course. Another way is to look at the amount of external funding that a group is able to get from a competition with other groups in the world or in the country. And I'm not going to tell you anything about this because I think it's not relevant to this audience and to this day of celebration. So what I thought I would do was rather tell you my personal experience as a member of the scientific community in the atmospheric and space sciences, what I feel makes the reputation of this institute in the world. Okay, but one way also to visualize the flux, the scientific flux of knowledge between the institute and the different countries is to look at the number of collaborations. So this is a view of different continents with a color code showing from gray, which is essentially 0, to very dark blue and black, the number of scientific collaboration that have been set up during the recent years. No surprise that the strongest ties between Institute for Space Aeronomy and other countries concentrate first on neighbor countries in Europe, Germany, France, of course, Great Britain, Spain, Italy, and other West European countries. As everybody expects, there are also a large number of scientific collaborations with the US and Canada. Now, if you sum up all these collaborations, you reach an impressive numbers of tens of scientific strong collaboration based on all aspects of aeronomy that have been put together in the recent years. Another aspect of international collaboration is the look at the nationality of the members of the institute. So here you have a sketch of Belgium with the Belgian scientist on the right-hand side, represented by more or less recent pictures. They are not located in the region where they come from what I can tell. And then you have this island on the left-hand side, who are the non-Belgian scientists, European or non-Europeans, which is actually a number that has grown in the recent years. And here I would like to just send a short message as a chairman of the Science Committee that current legislation, Belgian legislation, is somewhat to a limit for hiring foreign scientists who don't speak French or Dutch, just because the legislation is such that they have to be put in one basket or the other one. And it's always a problem to hire scientists from North America, India, or even some other countries. Okay, so what I will do next is, as I said a few minutes ago, is give you my own personal list of what I feel was and mostly is our essential contributions that are internationally recognized that has been initiated or are still being conducted by the Institute for Space Aeronomy. This is a non-exhaustive list, and those who work in a different field maybe will forgive me if I'm not quoting their own field. Guy Brasseur alluded to the pioneer role of Marcin Nicolai, and I think he even showed this reaction between ozone and atomic hydrogen, which is a loss process for ozone in the stratosphere. But incidentally, the OH, the hydroxyl molecule, which is produced in this process, is produced in an excited state and radiates in the infrared. So this radiation is, I'm not sure you can really see the red part of the radiation, but at least you can see the green part, produces what is called the air glow. These are chemical processes producing exothermic energy, which can radiate in the UV, infrared, or the visible. And in this case, this reaction has been known for the Earth for a long time, and I happen to be working on Mars Express and Venus Express missions, and very recently, in the very last few years, we found signatures of this reaction on Mars and Venus by looking at the infrared emission, and found the OH emission that was also, in the case of Venus, a first indication that ozone is playing a role in the photochemistry of the planet. And a little bit later, it was actually measured after the OH emission. The ozone was directly detected by a French group near Paris, with the SPICAV instrument on board Venus Express. Another aspect that was alluded to by Guy Brasseur was the ionosphere, where we now know that the atmosphere is just not only made of neutral constituents, but some of the air mass is electrically charged and plays an important role in the propagation or the absorption of radio emission or any electromagnetic waves, actually. This, as Guy Brasseur underlined it, a pioneer work by Marcin Nicolai on the explanation for the D region, the lowest of these layers, which plays an important role in the propagation of the so-called shortwave emissions, was put forward. Of course, these electrons cannot be directly detected by the eye or by optical instrument, but it turned out that a NASA mission a few years ago was for the first time able to image the ionosphere by looking at the effect of radiation interacting with this cloud of charged particles. These are actually helium plus ions surrounding the Earth. And it turned out, as was mentioned earlier, that the existence of a helium layer surrounding the planet was predicted by researchers from this institute before it was actually observed by mass spectrometers and by other instruments which detected helium in situ. So this is not, this is an active field in the institute, but this is also a very strong legacy of pioneers that initiated this institute. Another very active field, I think from very early on in the history of the institute, was the observation of the solar spectrum, and essentially it's an ultraviolet component. You have here a plot in the green or in the blue line of what the solar radiation looks like as a function of wavelength, the number of photons or radiation emitted versus wavelength on a log scale. And the red curve shows the variability, how much it varies as a function of the rotation of the sun or the solar cycle. And as you can see, one of the instrument, the SolSpec instrument, which is still flying on the International Space Station, has been able to show that the shortest wavelength show a much, much larger variation than longer wavelength, where if you look at on the scale on the right-hand side, the amplitude of the variation is more than 1, that is more than 100%, factors of 2 or 3 in the near and far ultraviolet. So this is another component of that really contributed to the reputation and still contribute to the reputation of this institute. Another aspect is, this was also mentioned with a somewhat different illustration, is modeling. In many fields of aeronomy, it's not really possible to get the full information from observations if you don't have modelers in the team, and these scientists at the Institute of Space Aeronomy have played a key role in extracting the useful information from these measurements. This is an example here of a nitric oxide, NO2, column density measured by satellite. And measuring is one thing. Looking for the sources is somewhat different. A step where you need models to go back to knowing the distribution of a component, such as nitric oxide here, is where it comes from and in what amount. And this is one of the expertise also that has been developed in the Institute. Many of these points that I am quickly showing here will be probably discussed in further details in the coming presentations. But I just want to give you an overview and, as I said, my own perception of the achievements of the Space Aeronomy Institute. Another aspect that has been extensively developed over the last few years is the physics of aerosols. Aerosols are these solid particles that float around in the atmosphere of the Earth. You can see here a picture showing part of this aerosol layer. They also play an important role in the chemistry, in the ozone chemistry, and they have been, many of their properties have been measured by the observation of their interaction with solar radiation. So by looking at the light that is scattered by these particles, one can determine these, at least some properties concerning their size and their distribution and their density. And this has been more recently extended to other planets like Mars and Venus, where analysis of the visible, infrared, and ultraviolet radiation has provided quite important and original knowledge on the role and the presence and the role of these aerosols in atmospheres from our neighbor planets. As was already mentioned, the concept of aeronomy that was developed very soon here in this institute was to extend it from the sun to the Earth atmosphere and other planets. So this is now going back to the sun, and as you know, the sun, the space between planets is not really an empty space. It is full with particles coming from the sun, both radiation and particles, and the Institute has played from the beginning also an important role in analyzing the properties of this solar wind, its distribution, the properties of the particles that leave the sun, hit the Earth and other planets, and interact with these atmospheres. This is just a plot showing the velocity in the ecliptic plane with the position of 3 different spacecraft measuring these particles in situ and showing how inhomogeneous this flow can be, at least at times. Some of these particles, as I said, interact when they come in the direction of the Earth, interact with the Earth magnetic field, and some of them are trapped in what are called the radiation belts On the left-hand side, you see a kind of an artist view. On the right-hand side, actual measurements that have been analyzed in the Institute for Space Aeronomy. You more or less recognized that the Earth is surrounded by two so-called radiation belts with essentially protons and electrons, and at least the electron population strongly reacts to the solar activity, whereas the proton one is more linked to the natural sources originating from the Earth itself. Now, it is also important to mention that this institute is not just an institute of a group of people who analyze data and make models. They also produce, design and produce instruments that have been carried on many different space platforms. This is just a picture of the SWAR instrument that was and is flying on Venus Express, at least till for, we hope, a few months or a year or so, which was designed in collaboration with the Latmos Institute near Paris, and which provides very, very high-quality results on the minor constituents of the Venus atmosphere, and are able to discriminate between the isotopes of some of these constituents and give a clue on the origin and the formation of these atmospheres. A very recent example, at least recent in the news, in the media, is the encounter of the Rosetta spacecraft carrying on board many instruments, including the Rosina mass spectrometer, in which the Institute of Space Aeronomy is involved, and you probably will also hear more about it a little later. Another aspect of the work that has been realized and recognized at the Institute for Space Aeronomy is its participation to global network. And this is maybe connects both the scientific aspect to the public service aspect, not just to the Belgium as a country, but to the world, is the involvement of the Institute in different networks measuring components from the ground. I'm showing here a map of various stations around the world in which the BISA Institute is involved, and especially the Reunion Island equipment, for which they really developed for the first time, and which is rather unique in this part of the world. So these global networks, as one can read, for example, in the IPCC reports, play an important role in controlling the evolution of the atmosphere, the natural but also the man-made compounds. This is the bromine oxide measured in Scandinavia, and they are essential in the control of the execution of some of the protocols that have been signed. It's not, signing protocols is important, but monitoring the effect is equally important. And BISA, with other institutes in Belgium and abroad, have played and is playing an important role. Another aspect of these networks is that many global measurements are now obviously made by satellite-borne instruments. These satellites have usually a rather short lifetime. They can measure ozone or other compounds for a few years, and then another instrument on board another spacecraft take over. And it is very important that they would be intercalibrated by a common source which is reliable. And that's where ground-based calibration is very important. They can, in a way, make sure that the continuity of the measurement is correct, and that the densities that are measured are not jumping from one value to a different one just because they are measured by a different instrument. And so this is part an important part of the activity in the BISA Institute. Now I have a few slides which I will get through very rapidly. First of all, I'll quickly mention that there are other networks than measuring densities of constituents. There's, for example, this network measuring the impact of meteors on the Earth's atmosphere and their detections. The BISA Institute is involved in missions which are either flying or will be flying soon, such as the Altius and Picasso small satellites for Earth observation, the SolSpec instrument, which I mentioned on the space platform, the Mars and Venus Express, the Rosina experiment on board Rosetta, which is measuring, has been measuring for a few months, the ExoMars mission, which is not in orbit yet, but which the instrument, one of the main instruments, the NOMAD instrument, is being actively prepared and I think will be ready soon in the coming month. The participation of the Institute is not just, not necessarily directly related to making instruments, but also analyzing data from instruments built by other institutes. I'm just listing here, I'm not going to read all this. Planetary and cometary missions, participation in team meetings for future mission. Space physics, Ulysses was an important mission. Cluster is also providing important data on the Earth magnetosphere and how the particles interact with the magnetic field. And finally, just to mention that the researchers in that institute also have played an important role in the development of software, which are used not only internally, but also available to the scientific and the engineering community at large. I will conclude in a few minutes, but I just want to emphasize a point that was briefly mentioned by Guy Brasseur, is about the budget. It's very hard to talk about science, especially space science, without mentioning the funds that are necessary to support this research. So this is a plot of showing how the funds that are available to the Institute have been evolving in their distribution between the three sources, so-called dotation, the subventions, that is the money that is coming from concluding contracts with organism, public or industry or Europe, for example, and finally some internal resources, which are only a small fraction. The message here is that if you look at the fraction of the budget that is provided by the dotation from the government, has been decreasing from 2010 to 2013 by a large fraction. And of course, this is a trend that has been observed in not just in this institute, but in scientific research in general and many other fields, but which is a little bit dangerous for the future. So I will terminate with three personal thoughts about what I think are important messages that I would like to convey. First of all is that BIRA is very highly regarded among the national and international community, and I believe that their future is bright if they are provided the funding and the support that they need to continue at least at their current level. A second message is that more and more funding sources tend to be oriented or guided. That is, especially in space research, projects are usually very long-term projects where things have to be very clearly defined, the cost, what exactly you want to do, and this is the way it should be. But no research institute can operate without a sufficient amount of money for new initiatives. That is, short-term project or projects that do not require these expensive infrastructures. So otherwise, it's clear that there will be no new initiatives coming from each institute that doesn't have the mean to develop its own originality. That's really the message I would like to give, is that apart from these space missions or big projects, it's important that part of the allocation may be used for new initiatives and for original team or personal research. And finally, efforts have been made by the government in the recent year to encourage collaboration between the BISA and universities. I personally, belonging myself to a university, I think this is very important. The BRAIN project started a few years ago and has already produced very interesting results. I'm convinced that this way of direction of action should be encouraged in the future, and I hope it will be. Thank you.